Welcome back. In this video, what we're going to do is actually move beyond our introduction to the units we use for concentration and put it into real life action. And so in order to do that, we're going to actually make a solution. And to do that, you'll have to put up with my makeshift lab once again. I was lucky enough to have enough glassware around to show you pretty accurately actually how we would prepare such a solution. So in this video, I'm going to show you a new piece of equipment here, and this is called a volumetric flask. And they're not the cheapest. We've got lots in the lab, and this one happens to be a 1,000 ml volumetric flask, or a 1 liter flask, so a pretty big one. Also, you'll notice that there's a little line at the very top. You may barely see that, and we're going to call that the mark. And the mark is a very important point in the flask in terms of volume, because it lets us know exactly when we have 1 liter in here. So this is much more accurate to measure a solution than a beaker, or even more accurate than this graduated cylinder, even though I'm going to be using this today as well. All right, let's make a solution. What we're going to do is prepare a solution that contains 50 grams of table salt, sodium chloride, in a liter of solution. Then we're going to take a look at the mathematics. Now, I've pre-weighed out 50 grams of table salt, and I'm going to actually dump it onto a piece of paper here so that I can transfer it. So I've got my salt in my paper, and I'm going to transfer that very carefully into my flask and hope I don't spill it. So here we go. We're going to add the table salt to the flask, slowly but surely. Got to be patient. If you're not patient, this process can be very, very painful for you. Patience rules the day. And that's pretty well it. So a handy dandy way to get a solid into a flask. Now, little technique here, much easier to swirl a flask when it's only half full than it is when it's completely full. Because when it's full, there's no room to mix, right? You gotta have air in there to help it mix. And again, salt's very soluble. This is a nice solution. We haven't yet got a liter. So I'm going to pour in the remaining water here and hopefully get it up to the mark. Now in the lab, we would probably do this a little more technically, but I'm going to go ahead based on what I have available. So let's pour this in. By the way, you would wear safety goggles if you were dealing with any chemicals that are dangerous. This is salt, so we're okay. And as I add it, we're not yet at the mark. We're getting there. And close. Now I've got an audience here. Let's see if I can do this fairly accurately. Getting close to the neck of the flask. And let's see what I'm doing here. I went pretty quickly. Not too bad. All right, so the bottom of that meniscus is on the mark, and we can now say that we've got a solution that has 50 grams of table salt in it in 1 liter. Now, let's go to the board and look at the math. Now, I've drawn a picture. I believe a picture's worth 1,000 words. There's our 50 grams of table salt going into our flask. That line on the top of the flask is called the mark. It does vary from flask to flask because it's very accurately determined, and each flask is made differently because it's actually made by glass blowers. So there's our picture. We did the demonstration. We can figure out the percent mass for volume of that solution because that's equal to the grams of solute over the milliliters of solution times 100%. Well, we weighed exactly 50.0 grams and our volume is 1,000 mils. Remember, 1 liter, 1,000 mils. Times 100%, 5.0% mass for volume solution. If we want to measure it in terms of percent mass for mass, or mass percent, then we take the grams of solute divided by the grams of solution times 100%, and that gives us a slightly different calculation. Interestingly, we have 50 grams of salt, and our solution weighs 1,050 because we had the water, 1,000 mils, and that's the density of water we know is 1 gram per mil, and we've added 50 grams of salt. So that gives us 4.76% mass for mass. The most important unit that we're going to be using in chemistry is the final one, and I mentioned this in my last video. That, my friends, is concentration. Concentration is equal to moles divided by volume, or moles per liter, of course. That is our unit. So if we want to find the concentration, we have to find the moles first. And moles is equal to grams divided by molar mass from our discussion in chapter 6, the original mole triangle. And we have 50 grams of salt divided by the molar mass of salt, which is NaCl, which I trust you can figure out, 1 sodium, 1 chlorine, gives us 58.5 grams per mole. Grams go bye-bye, and we get about 0.862 moles. Don't round off at this point. You always carry your decimals through the calculations. Now that we've got moles and we've got volume, because it's 1 liter, we're almost there. All we have to do is find concentration, which is moles over volume. So therefore, our concentration of our solution of salt is 0.862 moles divided by 1 liter. A very easy calculation this time. And we get 0.862 moles per liter. So that, my friends, is what we have in the flask. 0.862 moles per liter. If we use a smaller flask, we would have to change the volume. So 1 liter is quite convenient in this case. Now, that's quite a bit to cover in an 8-minute video. I hope it helped. Obviously, you need to reinforce this lesson by looking at the questions in chapter 8 and seeing if things work out for you. Until next time, we will look at diluting solutions, taking concentrated ones and diluting them down, kind of like Kool-Aid in water, if you will, and figuring out the mathematics of that.